over the past 5 or 6 years, I've done interviews with a number of experts around the world about the pace of the energy transition. On the one hand, you've got the Vaclav Smil folks who say it's going to be very slow, it'll be an evolution, not a revolution. On the other end of the spectrum, you've got futurists like Tony Seba who say it's going to be much more rapid than we expect, the transition to clean energy and clean technology. Kingsmill Bond from CarbonTracker probably falls into the Tony Seba camp. I've interviewed Kingsmill a number of times about the issue of the pace of the energy transition. He recently put out a study that argues that wind and solar and clean energy is going to be, again, is going to arrive much quicker than we had expected. So I'm going to talk to him about that. Welcome to the interview, Kingsmill.
Hi, Markham. Good to be here again.
Well, look, let's start with this. We've got a lot of ground to cover. And so let's talk about what's available. I'm kind of, the numbers are a bit shocking. I mean, you argue that the potential here is for wind and solar is 100 times current global energy demand. That's a big number.
It is a big number. And I think we were a little bit shocked when we figured it out ourselves. So what we did was quite simple. We just added up the total technical potential of solar and roofs and offshore wind and onshore wind from the best sources that we could find. And we contrasted that with total energy demand and total fossil fuel demand. And we did it per country and we added it all up. And as you say, the answer was the technical potential of these technologies is 100 times greater than our current total energy demand. And there are two really important qualification points I want to make about that. The first is that we deliberately used data which was quite constrained in and of itself. So we're not talking about every square inch of the planet being used. Solaris, for example, who did the data for solar, they exclude a lot of land. So they exclude mountains and cities and forests and roads and lakes and a whole series of areas from their data. And in fact, the total area, global area that they think could potentially be placed under solar is only about a quarter of the world, 27% to be precise. So that's one important qualification. And then the second is just to think about how this number has changed dramatically over time. Because if you look at pieces of research done 10 or 15 years ago, and probably the most famous is by David Mackay, Renewable Energy Without the Hot Air, was his book from 2009, where he basically said, look, I'm not going to bother to calculate the size of the solar technical resource because we're never going to get it. It's too expensive. And the size of the wind resource is a bit smaller than our total demand, 53 petawatt hours. And here we are, just about 10 years later, and the numbers that we're talking about for wind are 15 times bigger, and for solar is giant.
Well, let's talk about the costs. Anybody who follows the levelized cost of energy publications like Lazard or the US EIA, costs for wind and solar are now down at the low end below $30 a megawatt hour in US dollars. That's a tremendous, and they're forecast to drop even more by 2030, which means that wind and solar have tremendous economic potential, according to your study.
This then is the point, which is that just in the last few years, this technical potential has become economic. So it's hardly groundbreaking to say there's a huge technical potential out there, but what's extraordinary is that it's been unlocked in the last few years by the collapse in costs. So when the cost of solar, for example, in the US goes from $80 to 30 to 40 bucks, and therefore significantly below the cost of fossil fuels, it doesn't just unleash a competitor that might compete at the margin and be a bit of a pain. It unleashes a massive new energy resource, which means that very large swathes of land in every country of the world can be put to use to generate domestic local energy. So one of the points that we make is that in the report is that every country, almost every country in the world, has enough energy to have a gigawatt full of energy, gigawatt being the world's largest oil field in Saudi Arabia. Imagine if you woke up, in Portugal or or Rwanda and found this enormous energy resource in your backyard. That's what's happened.
Right. Well, let's talk about the amount of land required for this. So you've done some calculations for solar panels. And one of the things I found interesting is that the amount required globally would be less than the land required for fossil fuels today.
Yeah, I think this is a really important point to make, because you have a lot of skeptics who say, well, renewables are extremely lacking in energy density, and therefore you need a lot of land, and it's going to be difficult. We haven't got enough land. And there are two answers to this. First of all, the amount of land that you require is just simple calculation. You know, how many meters squared per megawatt hour per annum times the amount of megawatt hours you need. You know, gives you the amount of land. And the answer is it's 0.3% of the global landmass, 450,000 square kilometers, which again sounds quite a lot of land, until you take into account the fact that, according to Mark Jacobson, the oil and gas sector in the US alone is using 1.3% of the US landmass, or 126,000 hectares. And the reason why oil and gas, which in and of itself is indeed a very energy dense, the reason why it needs so much land is because it just takes a lot of land to get this stuff out of the ground, and then to ship it around, to transport it around in pipelines, and to refine it, and to have exclusion zones, because it's quite dangerous, all this all this work that's being done. So yeah, I think for us it was really astonishing that from his numbers, actually you need more land for fossil fuels than you need for renewables.
Well, let's talk about the how people will take advantage of all of this cheap energy. Now, Seba makes a great analogy, I think, and that is, he compares it to the adoption of internal combustion engine and cheap petroleum that really took off in the 1920s. And it transformed society as we know it. It led to the rise of huge cities and highways, and and the ability to truck food here and to places you couldn't otherwise do it economic. On and on and on and on. It transformed societies and economies. And you argue that essentially cheap electricity, renewable energy, can do the same thing.
Yeah, I think it's a really excellent observation of the great Tony Seba. That you just cannot try to forecast in detail how the future will be. All you can observe is that you've got this incredibly cheap new energy resource, which is getting cheaper all the time and is everywhere. And then you can say, well, we're going to use this in lots of new ways that you just cannot today forecast in any kind of detail. Precisely as you say, in the same way as 200 years ago, no one forecast that the exploitation of coal resources, or 100 years ago, the exploitation of oil resources would lead to so many new inventions. And this, incidentally, is why we're on the threshold of the most extraordinary cornucopia of technology innovation, in order specifically to exploit this new energy resource. And this, again, is one reason why I have so little interest in the forecasts of the current energy system forecasters, because they're basically they're the same. I think Seba makes this very good point that they're forecasting faster horses, basically, and not thinking about entirely new systems and how people will use energy differently. And that's how we need to think about how there's this new energy resource everywhere. Incidentally, the other point we make in this report is that the only other time in human history, there have been twice this has happened before in human history. The first is the shift from agriculture. The first is the shift from hunting to agriculture, and then the second is the shift from agriculture to fossil fuels. This is a similar order of magnitude.
Well, that is extraordinary. And so let's talk about fossil fuels, particularly oil and gas. Now, this is a sector of the energy industry that I cover, and I've interviewed many executives and other experts. And I think I can reasonably say that the oil and gas industry doesn't see this coming. I think it's baked into their culture that change will be very slow, and they have plenty of time, maybe at least 30 years, but probably closer to the end of the decade, to make their adaptations. And I suspect they're going to be caught flat-footed.
Yeah, I think you might have meant the end of the century, that that's what they're hoping that they can carry on doing. And I think people from this industry often say, look, demand's going to remain extremely large, and therefore we're absolutely fine. And you can immediately counter that argument just by looking around you. I mean, demand remains very high for coal, and yet the US coal sector has gone bust a couple of times in the last 5 years. Demand for conventional cars remains very high, and nevertheless, the car sector has had to reinvent itself and very significantly shift into electric vehicles over the last 2 or 3 years. And that's precisely the point, which is that you want to focus on marginal change, not on total size. Now, as for the propensity of incumbents to fail to recognize how the world is changing, I mean, that's absolutely axiomatic, as you know, Markham, and it's not just in the fossil fuel sector. It's not to point the finger at people in the fossil fuel sector. It's what normally happens. I mean, from the famous observation that IBM made after World War II, that the world had room for just 4 computers, to the McKinsey forecast that by the year 2000 there might be 100 million mobile phones, and the failure of the retail and media industries to switch quickly enough to the internet age, and so on and so forth. It's quite normal for incumbents, and there's even a textbook about it, Christensen's Innovator's Dilemma. It's very well known.
Right, and I mean, we have metaphors for this, like Blockbuster Video or Kodak, companies
Yes.
that were on the cusp and then suddenly weren't and went out of business, or their business model was transformed. Well, let's talk about how this might affect other countries. And you have 4 key groups of countries, and I'm fascinated by this because your point that countries, poor countries, suddenly wake up one day and have this enormous resource of cheap electricity in their backyard, cheap energy. That is the opportunity that they have been waiting for centuries, really, in order to speed up their development and their economic development.
Yeah, it's supremely significant. We shouldn't forget that the fossil fuel system in 200 years has failed to bring even electricity, let alone clean cooking, to billions of people across South Asia and Africa, and that in many countries, people lack the benefits of energy at all. And now suddenly you've got this cheap, widely distributed energy resource. You've got developed markets which are solving the policy and technology problems and are quite anxious to roll the technology out over the world, and consequently are highly likely, in fact, are already giving the technology and the policy insights to these countries. So I would suggest it's only a matter of time before they embrace it as a new development tool. And so what we did in this analysis is we looked at the multiple of renewable energy resource as a multiple of current energy demand. And it's quite interesting because the world breaks, as you say, into 4 groups of countries, and they range from those which we call constrained or stretched, where the amount of renewable energy resources is less than 10 times the amount of energy demand. So if you think about it, it means that in broad terms, you might have to put 10% of your land to work to generate your energy, which is a lot. And therefore, they're going to find it much harder than other countries. But the good news is there's not that many countries. About 6% of the global population falls into that bucket. So it's countries like Belgium or Germany. But at the other end of the spectrum, you have countries like much of sub-Saharan Africa, where the amount of renewable energy potential is over 1,000 times their total energy demand. And people often say, well, that's because their energy demand is incredibly low, but you could double or triple or even multiply it by 10, and you still have huge amounts of renewable energy resources. So what's going to happen, and we're already starting to see this is the exciting thing, is that in countries like Morocco or Chile, or Australia hardly counts as an emerging market, but Australia is a good example as well. Countries which have huge amounts of renewable energy resources per capita, they're already now starting quite aggressively to put into place plans to exploit this and to export this cheap renewable energy to other countries.
Yeah, that's an interesting point, because the countries that can export, tout exports to the importing countries like China and India. But China and India are very worried about energy security. They're not crazy about being reliant upon, others for their large percentage of their energy, and so solar and wind seem to be a big part of the energy security equation.
So this is the glory of obviously of solar wind. As you say, they are local energy sources by definition. There's a slightly boring and largely irrelevant debate about dependency upon imported solar panels and imported technology to make this stuff work. The reason why I say so bluntly that it's pretty irrelevant is simply because there's a huge difference between a solar panel which you buy once and lasts for 30 years and a barrel of oil which you have to buy every single day. Furthermore, because they're technologies, I mean, ultimately, if China were to switch off supply, you build it yourself if you're a big country, and it might cost a bit more, but ultimately you can do that. And you just can't do that with fossil fuels. You can't just suddenly switch them on. So if we then look at India and China, they fit into the kind of the second group of our countries where they're abundant in renewable energy resources. Is about 25 times as much in each case of renewable energy resources as their current energy demand. So it's not like they're not like Australia. They have huge resources, but they certainly have enough for themselves. And what that means, and we're already seeing this in both China and India, is that the governments are very aggressively pushing the deployment of solar and wind resources as a tool in order to reduce energy dependency. And this, incidentally, is why the idea that we could carry on in some kind of vision of business as usual is absolutely delusional, because put yourself in the shoes now of an energy minister in any country now, in any energy importing country. You basically got two options. Either you import fossil fuels from abroad, which creates a lot of energy dependency, or you stimulate your own domestic solar and wind industries and start generating the stuff at home. Well, of course you're going to go for the second one, and that's precisely what we're seeing in many countries.
Right. Well, let's wrap up our conversation with a discussion of Germany, because it's almost like you say it's a special case, and it's Europe's largest industrial economy. It's an industrial powerhouse, an innovation powerhouse. And even though it has very poor solar and wind resources, it has tremendous innovation resources, and it can almost innovate its way out of its energy problems. I don't know if I'm described that accurately, but what's your response to that?
Well, the reason why in the report we highlighted Germany is because it's often thrown in my face that the energy transition has been incredibly expensive for Germany, and there's huge domestic resistance to the further deployment of wind, and they're having to build these huge grids, and it's very difficult. And people basically go, look, gee, it's really, really hard for the Germans. We can't do this. And the answer to this one is, well, first of all, as is widely appreciated and known, Germany is a bit of a special case because Germany was such a leader and they incurred a lot of initial cost to get this whole thing off the ground. Thank you, Germany, as it were. But secondly, and we hadn't realized this until we did the report, Germany's a complete outlier. It's only got about 2.5 times, from our calculations, 2.5 times the renewable energy resource compared to its total energy demand. And that doesn't mean that it can't be done, because actually lots of clever solutions. But what it does simply mean is that it's going to be harder in Germany, and Germany has to be considerably more flexible. And therefore, actually, the problems being faced by Germany are by no means normal, and by no means going to be replaced and replicated in other countries. Or to put it in a more positive sense, if the Germans can do it, basically everyone can. I think it might be helpful on that subject to talk a little bit about a couple of the other angles that we wanted to mention in this report. One is that for the continent of Africa, it's a kind of renewable superpower with kind of the other end of the spectrum from Germany, as it were, with 39% of the total resources, and of course growing population, and a desperate need for more energy per capita. I mean, it's such an obvious solution, which means that the idea of Africa getting rich on fossil fuels, or importing, as I know a number of people are talking about, importing LNG and other fossil fuels from the United States is just completely without foundation. then I think yeah, the other point that we wanted to make in this report is that this renewable energy is a little bit like sunshine. I'm in a room with my blinds down at the moment because there's too much sun coming in, but it's coming around the edges, coming around the side. And that's the way to think about this renewable energy resource, is that people have got to stop thinking in their kind of siloed terms. We can't have renewable energy in plastics because it can't be done. Well, okay, fine. That the plastic sector is, as it were, the island at the top of the fossil fuel system, which will be the last piece of the system, or one of the last pieces of the system, to fall beneath the waves of the rising renewable tide. But there are many, many other sectors which are being transformed. And that's how this transition will work, is that one sector after another, one country after another, this renewable energy resource, which has just recently been discovered, will find its way through and will find solutions. And that's what this big technology innovation era is going to be all about, finding solutions to get this stuff to work.
Kingsmill, always a pleasure. And I suspect we'll be talking again in the very near future about the pace of the energy transition. Thank you very much for this.
Brilliant. Thanks, Markham.